1, 4. Ah, this is great. Now I got it. So then we sum these two guys together. They just asked us to sum A plus B. That would give us 3. All right, I made a small mistake. Okay, so great example. I don't know how long that took me. A few minutes, certainly, 2 or 3 minutes. With a mistake. This is all adding up to the idea of definitely just skipping this one, right? So the answer here was B. It was 3. That's number 9. Yep. Okay, so you can solve this. It's usually not the ability to solve it, but it's about the idea of you may not need to solve it, right? It may not be worth your time. So keep that in mind as you progress through the test. There's 2 of those so far. Which of the following equations has the graph in the xy plane for which the y is greater than or equal to -1? Okay, weird. Which of the following equations has a graph in the xy plane for which y is greater than or equal to -1? So here's like -1. So let's see. This would be, this first one would be -2. No, because that would be down here. This is all about just translating equations. So this is stuff that we've actually done before. We should recognize this. This one would be down 2 again. So let's see, but opening upwards. But it says, which of the following equations is the graph in the xy plane for which y is greater than or equal to -1? No, it has pieces below it. So this is also too low. This one right here. Ah, this is good. So notice this is the only one that shifted to the right, right? So I would guess C. Yep, that's correct. So this one looks like this. This is like 1, 2. So all the other ones had things beneath it. I can draw out all these if you're curious. So absolute value -2 is down here. It looks like this. So they're saying they want something that is above this line of y equals -1. So that's that line there. So notice that the absolute value one is down at -2. The parabola is down at -2. Cool. The cubic function is down at -2. That would look like that. And then the only one, C, is shifted to the right 2, right? So it's a parabola just to the right 2. It's the only one that's above the -1 line. Okay, that one is just a graphing problem. It's a good one, honestly. All right, good. Okay, this is the one that was probably most asked about. So let's take a look at this and see how this goes. Let me fix this real fast. Okay. Okay, so even before we jump in here, we see that we have an irrational component in the denominator. We have this 2i in the denominator. So without even looking at the answers, you know that you need to rationalize this. So how do we go about rationalizing it? Let's play around and see if we can recall. There's lots of fancy names for this, but you don't actually need to know the names at all. You just need to know how to do it. So we need to say 3 minus 5i divided by 8 plus 2i. Okay, we need to multiply by the complex conjugate. So all that really means is that we want to get rid of this imaginary component, this piece right here in the denominator. So the only way to do that is to multiply it by something like this, 8 minus 2i. So the only way to really get rid of an imaginary number is to multiply it by another imaginary number, and specifically a negative one. So the negative version of this imaginary number cancels out the central terms, right? So the multiplying will get rid of the I. The subtraction gets rid of the central terms that are created with imaginary components. So if you do it on the bottom, you have to do it on the top. 8 minus 2i. Okay, so you can see this is going to be quite complicated as far as the algebra goes, but it's not bad. We might be able to shortcut this quickly by just solving for the denominator. Notice we have 34, 34, 8, 2, 8, 2. So let's see what we get. So let's say 8 times 8 is 64. We need to do this top one too. Man. Okay, let's do the top. Let's do the numerator first. 3 times 8 is 24. Cool. Let's go let's go minus 6i minus 40i. Notice these central terms have it, but it's okay in the numerator. And then plus a 10i squared. Now, look up here, they give you this idea here. They don't really say it, but they also need to say I squared is equal to -1. That's the big thing you need to know. So all of that is divided by, let's get to the bottom. So we get 64, right? Minus 16i plus 16i. Notice this is canceling. And then minus a 4i squared. Cool, let me get rid of a bunch, or I'll just come over here. Let's clean this all up. So this piece right here becomes a -10, right? So we get 14 minus, and it looks like 46i divided by, over here this becomes a +4, this piece right here, right? Because I squared is -1. So it becomes +4, this becomes 68, and that's it. So it's 14 minus 46i over 68. Whew. Okay, so that really boiled down. So now, notice that we can do some canceling. We can pull a 2 out of all of this. Can we go further? Maybe. So let's break this into two things really fast. Okay, so they have it in two answers, so let's break this into two. So 14 over 68 is going to give us what? So let's go half, half. That gives us our 7 over 34. Cool. Can we go further? Can you simplify that further? If not, then we know the answer, right? Or we're going to narrow it down to at least 2. So does 7 go into 34? No. So that it's going to be one of these two here. Now let's do the next part. So if we half this, we would get what? Minus 23i over 34 as well. And that is it. I don't think we can go any further. 23 is pretty hard to reduce. Okay, so that's the answer. So just one little bit of reducing. If this looks crazy, I apologize. Wish I had a big board to write on. Okay, so this is called rationalizing the denominator with a complex conjugate. That's all. So what were the take-homes from that? You just need to be rapid with your algebra. You need to know that I squared is -1. And you need to know how to actually solve for the complex conjugate. Okay, almost done. 12 is not too bad. So R equals F over N plus F. So, and they say blah, 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 blah. Which of the following expresses the favorable reviews in terms of the other? Okay, wait. So they want to know, they want you to solve for F, basically. So let's solve for F. Oh, this is going to be interesting. So how would one solve for F? Well, let's start by cross multiplying. So we get Rn plus Rf equals F. So that's the first move. I just cross multiplied, right? And then I'm going to bring the f's on one side. So I'm going to say Rn equals F minus Rf. I'm going to factor out the f's. Rn equals F times 1 minus R. Cool. And then I'm going to divide by that. 1 minus R, 1 minus R. Cool. So I get F equals Rn over 1 minus R. So F equals Rn over 1 minus R. I got that one. 12B. Correct. Okay, playing around with some algebra again. Not the end of the world. Double check that you understood how this works. Cool. Way easier than the previous ones. So that one was one you definitely want to jump on. Let's see. What is the sum of all values of m that satisfy? Okay, so now, in a real test scenario, since I'm just kind of going over this, in a real test scenario, you would totally skip these or just read them very briefly and then move on. So I'm only doing this just in case you're curious about learning about these things. But absolutely move on if you were in a real test environment. So what is the sum of all values of m that satisfy that equation? Interesting. So they want you to sum the values of m. So this is just a quadratic. So let's quickly solve that. So how do we factor this quadratic really fast? Well, we have 2 as a coefficient in front of m squared. So look, we can take the 2 out. So 2, and then we get m squared minus 8m plus 4. Cool. Cool, and this all equals 0, of course. And then we can factor this. So then we can say, and this 2 disappears. So now we can just say m minus 4, that's a perfect square, is it not? Excuse me, m minus 2 squared equals 0. All right, let's double check if that makes any sense at all. Good, looks like it does. M squared, oh no,